Today we're going to look at factorising the difference of two squares. So remember that if we expand this binomial product here, a plus b times a minus b, that we get this form, a squared minus b squared, and that's called the difference of two squares. When we're looking at, if we factorise the difference of two squares, we look at doing the opposite to expansion. So we're looking at going from the form a squared minus b squared, so finding an expression that's in that form and converting it into the form a plus b times a minus b. So converting it into a binomial product. So for example, if we've got here x squared minus 16, that's the same as x squared minus 4 squared. So for this form here, the x is going to be a and b is going to be 4. So if we're putting this into the form a plus b times a minus b, this is going to be a and this is going to be b. So this is going to be x plus 4 times x minus 4, and that will be the factorised form of x squared minus 16. Now if we look at 9a squared minus 100, this first term here, to find exactly what that whole thing is, what a squared is, we need to make sure that we take the square root of the whole thing to show exactly what that whole term squared is. So 9a squared is actually 3a all squared, because 3 squared is 9 and a squared is a squared. And then minus 100 is 10 squared. So here a is going to be 3a, a from this is 3a, and b is 10. So it's going to be 3a plus 10 times 3a minus 10. That's this expression factorised. So that's the factorised form there. Okay. Lastly, last example here, 25 minus 4y squared. 25, that as a perfect square is 5 squared, and this 4y squared here as a perfect square is 2y all squared, because 2 squared is 4 and y squared is y squared. So that means a is 5 and b is 2y. So here 5 plus 2y times 5 minus 2y. Now these are all very convenient because they're all perfect squares, each of them. This is a perfect square, that's perfect square, that's perfect square, that one is. But if we have one that isn't perfect squares, we need to make sure we find the highest common factor and remove that in order to start the factorisation process. So here, neither of these are perfect squares. 2x squared isn't a perfect square because 2 isn't a rational number, and 18 isn't a perfect square either because it's not. If I wanted to find the square root of 18, that is not going to be a rational number either. It's going to be absurd. So we do have the highest common factor of 2 between them though, so we can take that outside, divide both of the terms by 2 and say 2 times x squared minus 9, because 2x squared is 2x squared, minus 9 times 2 is minus 18. So what we have in the brackets here now, this expression in the brackets, is a perfect square. We've got x squared minus 9, is the difference of perfect squares, sorry, the difference of two perfect squares. So x squared is a perfect square, and so is 9, because 3 squared is 9. So here x is the first, is a, and 3, because 3 squared is 9, is the part b. So this is going to be the expanded form of that part in the brackets is x plus 3, x minus 3. Okay, and then we multiply by the factor, the highest common factor that we've taken outside the brackets. Let's look at some examples now. So the first one here, x squared minus 4. So that is the same as x squared minus 2 squared. So this is a and this is b. So here we've got a plus b, a minus b, a plus b times a minus b, a being x and b being 2. So we get x plus 2 times x minus 2. Here, 18x squared minus y squared. Now, 81x squared minus y squared. So this first term here, as a perfect square, is 9x all squared. 9x all squared, because 9 times 9 is 81, and x times x is x squared. And y squared is its own perfect square there. So here, that means that the factorised form is going to be 9x plus y times 9x minus y. Now next one down here, neither of these are perfect squares, so we need to make sure that we can take the highest common factor out from those terms, which is 2. We can divide them both by 2. Taking that outside, we're left with b squared minus 16. That's the same as b squared minus 4 squared, so they are both perfect squares there. And we're left with then, if we factorise the b squared minus 4 squared, b plus 4 times b minus 4, all multiplied by 2, which is the highest common factor of those terms when we took them outside the brackets. Now, here we've got x plus 1, that all squared, which is a perfect square because it's all squared, and 4 is a perfect square as well. It's 2 squared. So x plus 1 all squared minus 2 squared. So x plus 1 is our a, is our first term, and our b is 2 there. So our here is x, in factorising it and putting it in this form, x plus 1 plus 2 is the first term, and then x plus 1 minus 2. So here's the x plus 1, and then we add 2 and subtract 2 for the difference of 2 squares factorisation. So we can then simplify that by collecting like terms. X plus 1 plus 2 is x plus 3, and x plus 1 and subtract 2 is going to be x minus 1. So we're left with x plus 3 times x minus 1.